Hello students, welcome to the next lecture on the residue. This is the part third of the special function. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the previous two lectures, residue of the functions and the residue of the pole. You can find the playlist as the complex analysis. Now, as I mentioned you, we have discussed the two different types when the poles are my simple and when the poles are order greater than 1. Then we can use the residues of these formula. For more detail, you can watch about my these two previous lectures. Now, in this lecture, we will find the how you can find the residue of the some special functions. Fine. What is the meaning of the special functions? That means whenever you have the terms involvement of the exponential, cosine, tan, cot inverse and so on. बड़ा ही आसान तरीका बताऊंगा इस लेक्चर में. जब भी आपको स्पेशल फंक्शंस इनमें से कोई भी दिखाई दे जाए, आप और भी लिख सकते हो, tan इनवर्स लिख सकते हो, आप साइन ऑफ जेड लिख सकते हो एंड सो ऑन. जब भी आपको स्पेशल फंक्शन दिखाई दे जाए, you can get the answers within the 15-second time periods after watching my this video. Remember, whenever you will see such function appears, always apply the series expansions. Series expansion means you can use either as a Taylor series or any of the other series to expand them. Once you can expand the series, for example, we all know what is the series of the e raised to power z. 1 plus z square over 2 factorial and so on. That is the meaning of the series expansions. Once you can expand the series, then you can find the coefficient of 1 over z minus z. Fine. सिर्फ इतना ही करेंगे, 15 सेकंड में आपके आंसर आएंगे. हाँ, आप इन क्वेश्चन को इन दो मेथड से भी सॉल्व कर सकते हैं. यू कैन ऑल्सो सॉल्व द स्पेशल फंक्शंस, हाउ यू कैन फाइंड द रेजिड्यू बाय आवर प्रीवियस टू लेक्चर्स. दैट्स वेल, बट दैट विल टेक अ लॉट ऑफ द टाइम. So that's why I'm using the third lecture, which is very crucial for you. उम्मीद करता हूँ एग्जाम्पल देखने से पहले you can like and comment on the video. Look at the first example. Your target is to find the residue of the function. Clearly say the function sine z is given, which is my special part. Fine. So that means you may use as a lecture number 1 and 2 as well. Now, whenever you are using the special functions, always remember, whatever the point is given to you, the point is say z is equal to z naught, then your target is to express the given function fz in terms of z minus z naught. In this particular example, z minus z naught is which is similar as a z, and you can written as here, or you can see I can written the function is z minus z naught divided by sine cube of z minus 0. That's the same thing. But if somebody will ask you, you can find the values at the point 1. Then your target is to write the value of the fz in terms of z minus 1. So I can minus of the z1 and I can plus 1. Similarly, I can write for the denominator, it is z minus 1 and I can add plus 1. So you can see the term is related to the z minus 1. Fine. These are first steps. Second is, if the point is not given to you, then how you can find that? You can find the pole of the functions. How you can find the pole of the function? You can put the denominator as a 0. For example, you can substitute the sine cube is my 0. This implies sine of z is my 0. This implies z is equal to n pi with the multiplicity. What is the multiplicity of these functions of this pole? Multiplicity is my 3. So that's depending from the problem to problem. If the point is not given, then you can find the point by using the pole. If the point is given, then you can use as directly. Now I can start with them. समझ में आ गया इतना? Okay? उसके बाद आप 15-15 सेकंड में आंसर निकालेंगे. So let's start करते हैं. Because a special function है, then our target is to find the residue by using the coefficient of 1 over z minus 0. So now, do you know what is the expansion of the sine z? Because it involvement of the sine z, we all know this value is z minus z cube over 3 factorial plus z raised to power 5 over 5 factorial and so on. Fine. You may remember the standard series or you can apply the Taylor series for them. Then target is to write the first term to be 1. How you can write that? I can take the z is my common. I can write as a z is common, then it is a 1 minus z square over 3 factorial and so on. Therefore, look at the given expression. I need the value of the 1 over sine z. So can you find the value of the 1 over sine z? I can take it as a inverse of the expansions. Now you can expand the series. What is the series is 1 minus x raised to power minus 1. And we all know the series expansion is 1 plus x square. So I can open this value. It is 1 plus x z square over 3 factorial plus and so on. Fine. Now substitute the value in the given function fz. The value is z. This value is my 1 over sine cube. So I can take it as a cubing on the both side. Fine. So this number is my z cube and I can return this part is my cube. Fine. Now you can open this bracket. It is 1 over z square. It is a plus b plus c whole cube. So it is 1 plus z6 over 3 factorial square. Similarly for the second term and so on. Fine. Now your target is to find the coefficient of the 1 over z. Now clearly say it has already as a 1 over z. So when it will be the coefficient of the 1 over z? When this value we can find the coefficient of the z. ऐसे तो मिलेगा ना आपको 1 over z, बिकॉज ये ऑलरेडी 1 over z स्क्वायर है. तो 1 over z कब मिलेगा? जब यहां से आप सिर्फ कोफिशिएंट ऑफ z का निकाल लीजिए. फाइन. पर क्या आपको इसमें से कोफिशिएंट ऑफ z कभी मिलेगा? कभी नहीं मिलेगा, बिकॉज इसकी पावर कितनी है 3. तो ये सारे टर्म्स आपको 3 की टर्म्स में मिलेंगे. तो कोफिशिएंट कितना आया आपका? 0. एंड यू कैन सब्स्टिट्यूट हियर. आंसर इज 0 इज द राइट. फाइन. द रेजिड्यू ऑफ द फंक्शन इज माई 0. This is the first method. Fine. The second method is you can solve the problem. You can see z is equal to 0 is the pole with the multiplicity 3. So जैसे 3 multiplicity है, you can find the second type of the lecture and find its pole. Find the residue by using the second derivative of the functions fz divided by 1 over 2 factorial. Limit z approaches 0. That's on your choice. Fine. Okay, look at the second one. So given function is my cot. This is my, I can written as a cos over sine. Fine. Now you can see I will tell you the two different methods. First method I will tell you with the help of the type 2 and second method I will tell you with the help of the shortcut twigs. Now how you can solve that? Firstly, first method is, can you find the pole of the functions? How you can find the pole of the functions? The pole is denominator as a 0, which implies z square is 0 and sine of z 0. This implies z is equal to 0 comma 0 and z is equal to n pi, where n is my integers. Fine. So what does it implies? That implies z is equal to 0. 1 0 will also be there with the multiplicity 3. And while for the other case, it is plus minus pi, plus minus 2 pi, all are my simple poles. Is it okay? Now our target is to find the values at the 0. So I can use the type 2, that is a limit z approaches 0. The multiplicity is my 3. So 1 over 2 factorial. Second derivative of the function z cube into fz. Fine. Now I can substitute the value of the fz. This is my fz. So z cube and 1 z will be cancelled out. Now how you can find the second derivative? So I can take 1 over 2 factorial is outside. Z approaches 0. So firstly I can take the first derivative. What is the first derivative of the function? It's a sine square z. This is my sine z into 1 of cos z minus z of sine z. Fine. Minus z of cos z into sine. Sine is a cos, it's a cos square. Is it okay? Now you can open the bracket. Half is outside. Limit z approaches 0. First derivative. Now you can see this is the my minus z sine square. And this value is my minus z cos square. So this value becomes my minus of z. Sine square plus cos square is 1. Now again, you can find the derivative and you can see it's a very time consuming, or you can see it's a very lengthy calculation, and once you can substitute the value as a 0, it is always with a 0 by 0 form. Then again you have to use the derivative again and again. So that's a very lengthy calculation. Fine. So that's why whenever there is a special functions, you can always apply the second method, and that is much easier than of the previous method. क्लियर बच्चों? हमेशा ही जब भी स्पेशल फंक्शन दिखाई दे, आपका CSR नेट का एग्जामिनेशन है, थ्योरी एग्जामिनेशन है, हमेशा ये वाला मेथड अप्लाई करिए. तो इसलिए क्या करना है आपको सिंपल पहले तो 0 की फॉर्म में लिखना है, इट इज ऑलरेडी देयर. तो आपको कोट ऑफ जेड की सीरीज पता होनी चाहिए. फाइन, you can apply the Taylor series or you can remember the standard one. Then can you find the value of the fz? Fz is, I can substitute the value divided by z square. The first value is my z cube, second value is my 1 over 3z, next value is my z square over 45 and so on. Is it okay? Now you can see clearly say this z is equal to 0 is the pole. You can also find the pole by using the expansions. What is the highest power of the 0 is 3. So pole of order 3. Fine. And once is the pole of order 3, you can find the residue is, how you can find the residue of the functions at the point 0. Residue of the function at the point 0 is coefficient of 1 over z. So can you find the coefficient of the 1 over z? Coefficient of the 1 over z is minus 1 over 3. So that's the answer of this problem. You can see that within the 15 seconds you can get your answers by using the expansion series. उम्मीद करता हूँ आप वीडियो को लाइक एंड कमेंट जरूर करें. Okay, find the residue of the functions. Again, our target is to write the given functions with respect to the z minus 0. It is already there. Fine. So let's start with the tan of z expansions. Fine, because it's the special functions. So do you all know the expansion of the tan of z? Z plus z cube over 3, z5 over 5 and so on. Now you can substitute the values in the given functions. Or you can also write the values as e raised to power z 1 plus z square over 2 factorial and so on. Clear? Our target is to make the first value as a 1. So I can take an z is my common. Now I can find the value of the 1 over tan z. So that means 1 over z I can written as a minus 1. Now we can use the expansion 1 plus x raised to power minus 1. It will be 1 minus x plus x square minus x cube and so on, provided the value of the x must be less than 1. And clearly say this value must be less than 1 because at the point 0, this number is my 0. Now you can open this series 1 minus x. Fine. Next number is again z cube by 5 and so on. Is it okay? Now you can substitute the values in the given fz. E raised to power z divided. Now again I can expand the series of the e raised to power z. This is the value of the e raised to power z. Now how you can find the coefficient of 1 over z? Look at that. There is a term of the 1 over z. तो इसके अंदर क्या होना चाहिए आपका? ये कब coefficient ये कब बनेगा? यहाँ से आपको सिर्फ कांस्टेंट टर्म ही तो चाहिए. फाइन, बिकॉज ऑलरेडी 1 over z appears. So can you find the constant term? Constant term is only 1. Fine. The next term is a z square, z cube and so on. So the constant term is 1. Therefore coefficient of the 1 over z is 1. So residue is also my 1. Look at the next part. Find the residue of the functions at the point z is equal to 0. Again the 0 is already written. Remember student, if it is written as a pi, your target, then you have to write the function z in terms of the pi as well. So I can minus pi plus pi. Similarly, e raised to power 1 minus pi plus pi. I will also explain such kind of the example in the in this video as well. So you can stay with this video till the end. Now you can expand the series. What is the expansion of the e raised to power x? 1 plus x square over 2 factorial and so on. You can see 1 plus x square over 2 factorial, x cube over 3 and so on. So can you find, again it's a special function. Can you find the coefficient of the 1 over z? So clearly say this is a multiply by z4. So which term you needed to find the coefficient of the z1 over z? I need the coefficient of 1 over z5. So that means Answer is 1 over 5 factorial. Fine. So therefore residue is 1 over 120. Look at the second term. Next example. Find the residue of the log of ln of z divided by z square. First of all, you can see the ln of z. Ln of z is, is it the pole? No, because the function is not analytic at the point z0, because z is equal to 0 is my branch point, and once the function is not analytic, that means it does not represent the Taylor series, and once it is not represent the Taylor series, so it means it does not have any pole. Once it does not have any pole, so the residue is my 0. Fine. So that means the residue is my undefined at the point 0. Always remember, student, whenever you are trying to expand the logarithm series, it must be of the log of ln of 1 plus z, not only as the z. So that's why the residue is my undefined. Okay, look at this term. Again, this is a special function, exponential part, sine of z, about the point 0. Fine. So again, it's a coefficient of 1 over z. How you can write it? It is always 1 over z minus 0. So let's start with the sine of z. We can expand the series. Our target is to make this value as a 1. ये 1 आपको तब बनाना है जब स्पेशल फंक्शन आपका डिनोमिनेटर में हो. ओके, अगर ये न्यूमिनेटर में होता फिर जरूरत नहीं है आपको. फाइन, ये डिनोमिनेटर में है आपका. Then your target is to make this number as a 1. Always remember, you can make the term as a 1 only when the special function appears in the denominator. When the special function appear in the denominator, then you can make as a 1. So how you can make them as a 1? I can take z as a common and I can write the series. Now your target is to find the value of the 1 over sine z. I can write as a 1 over z raised to power minus 1. I can open this series by using the binomial expansions. We will get, you can firstly write as a minus of 1 and then you can use as a series. So it will be 1 plus z square over 3 factorial and so on. Clear? Then I need to find the value of the 1 over z cube into sine of z. So I can multiply 1 over z cube on the both side. It's a 1 over z 4 into e raised to power iota z. Again, these are special functions. So I can expand the series e raised to power z. Fine. Now can you compare the coefficients of 1 over z? So how you can compare the coefficient? It's already a 1 over z raised to power 4. तो यहाँ से क्या मिलना चाहिए आपको? ये कोफिशिएंट किसका होगा? जब आपको 1 over z चाहिए, so you can equate the coefficient of the, you can only equate the coefficient of z cube. Then only it will be 1 over z. So can you equate the coefficient of the z cube? So for the first term, it is my iota cube divided by 3 factorial. Next term will be z square into z plus iota divided by 3 factorial. इसके अगले क्या आएगी? It's a z raised to power 4 over 5 factorial. So it is my z raised to power 4 over 5 factorial. So ये टर्म कभी भी आपको z क्यूब नहीं देगा. So आपका कोफिशिएंट क्या बन गया? iota क्यूब divided by 3 factorial and it is z square into this. So what is iota cube? It's a minus iota over 6 plus iota over 6. Answer is my 0. So coefficient of the 1 over z is my 0. Hence residue is also my 0. Look at the next terms. Now you can see that this is not a 0. So your target is to find the coefficient of 1 over z minus pi. So then your first target is to express the given functions in terms of z minus pi. How you can write that? In the numerator, I can subtract minus pi plus pi. Fine. And the denominator is already z minus pi. Fine. Now you can see in the numerator, what is the value of the cos pi plus theta? It's a minus cos of theta. So I can written as it's a minus cos of z minus pi divided by z minus pi cube. Fine. Now you can see all the expressions are written in terms of z minus pi. Now you can expand the series of the cos of x. What is the cos series? 1 minus x square over 2 factorial, x4 over 4 factorial, and so on. In this case, x is my z minus pi. So can you find the value of the fz? So I can substitute the value of the cos in the numerator and I can divide it by this one. Fine. So it is a 1. Oh, sorry, it's a negative also. So I can write as a minus, it's a positive, it's a negative. Fine. Now can you find the coefficient of the 1 over z minus pi? So clearly say the coefficient of the z is, this is number is, because it's a negative also. Fine. So this number is negative. So it is a positive. So answer is 1 over 2 factorial is the residue. I can also solve the same problem with the help of the other methods. Like I can start with the pole. Can you find the pole of the functions? The pole is z minus pi whole cube 0. This is the second method for the same problem. Can you find the pole? So that means z is equal to pi is the pole with the multiplicity 3. So once it's a multiplicity 3, so how you can find the residue? So z approaches pi 1 over 2 factorial d square upon d into z cube of fz. Fine. I can substitute the value of the fz at the here. 1 minus z minus pi square will be cancelled out. So in this case, instead of the z, because my target is to find the values at the pi, so this number will be z minus pi cube. Now you can substitute that. This value will be 1 z will be cancelled. It's a z minus pi. Fine. Now you can take the 2 times derivative, and after solving the 2 times derivative, your answer will again be 1 over 2. Fine. But in that case, you have to need the 2 times factorial. So that may take a lot of the time. So the best way is you can solve with the help of the coefficient method. Okay, look at this next one. Find the residue of the functions at the point 0. So again, it's a simple 0. So the coefficient residue is coefficient of the 1 over z. So start with the tan inverse z expansions. So you can start with the tan of z. Again, this part is not in the denominator. तो यहाँ पे 1 बनाने की बिल्कुल भी जरूरत नहीं है. There is no need to make them as a 1 because tan inverse is not in the denominator. It is already in the numerator, so it is fine. So I can find the value of f of z. So I can divide it by z square. This value is minus z over 3 and so on. Fine. So can you find the coefficient of 1 over z? Coefficient of the 1 over z is my 1. So therefore residue is my 1 is the right answer. Look at the next one. Find the residue of the cos hyperbolic. So again, it's a z is equal to 0. How you can find the series of the cos hyperbolic? We all know the cos of the x is 1 minus x square over 2 factorial, x4 over 4 factorial, and so on. So based on this, you can easily write the cos hyperbolic x. The cos hyperbolic will be 1 plus all are my positive. Fine. Similarly, if the term will be my sine of x, how you can find the hyperbolic sine of x series? Sine of x will be x minus x cube over 3 factorial, x5 over 5 factorial, and so on. And cos sine hyperbolic will be all are my positive signs. Fine. This is the way you can remember the series. Now let's start with the cos hyperbolic series. So you can start with the 1 plus z square over 2 and so on. Again, the cos hyperbolic is the numerator. There is no need to convert into the 1. So can you find the value of the fz? So I can substitute the value in the given functions. It is 1 over z cube plus 1 over 2 factorial into z, z over 4 factorial and so on. Fine. So what you can obtain from this case? So that also implies that z is equal to 0 is the pole. What is the highest degree? 3. So pole of order 3. Fine. Or otherwise, if you want to find the residue, what is the coefficient of the 1 over z? So clearly say the coefficient of the 1 over z is 1 over 2 factorial. That means 1 over 2 is the answer of the residue. Look at the next one. Now you can see it's a hyperbolic. Fine. So I can start with the sine hyperbolic. Again, the sine hyperbolic is written in the denominator. So I can try to make this value as a 1. I can make z as a common. Fine. Then I can find the value of the 1 over sine hyperbolic. I can written as this is 1 over z, and the term will be minus of 1. I can use the series expansions of 1 plus x raised to power minus 1, 1 minus x, and so on. Fine. I can substitute this value in the given functions. You can get f of z is z over z cube. So this value will be 1 over z square. I can open the cube. It's a 1 minus z raised to power 6 over 3 factorial cube minus and so on. Fine. So can you find the coefficient of 1 over z? When it will be the 1 over z? When you can find the term which is involvement of the coefficient of z only, but there is no term involvement of the z. So the coefficient is my 0. So once it's a 0, residue is also 0. Again, look at this next term. You have to start with the cos hyperbolic. That's again similar one. You can start with the cos hyperbolic series. Substitute the value in the given functions. Your f of z will be 1 over z cube plus so on. So can you find the coefficients of the 1 over z, which is equal to 1 over 2 factorial? So answer is half is the right. This is a similar same. This is the same question. This is a repetition, so I can skip that. This is the same question. Fine. Now find the residue of the given functions at its pole. Can you write the given function is e raised to power z over sine square z? Fine. Now you can see this is the special function again. So let's start with this. At firstly, the point is not given to you. At which point you need to calculate the residue? It is not given, and they are talking about the poles. So can you find the pole of the function? The pole means the denominator has a 0. This implies sine of z is 0. This implies z is equal to n pi of multiplicity 2. Fine. With the multiplicity 2. Also, because this is a sequence, so can you find the limit point of the pole? What is the limit point of the pole? Limit point of the pole is z is equal to infinity, because if you take limit as n approaches infinity, you can watch this lecture of limit point of the pole. That is already I uploaded limit point of the pole. How you can find the limit point of the pole? So therefore z is equal to infinity is my isolated singularity, but we always taken on the finite plane. Fine. So now because they are of the double order, fine. So the way you can compute either by using this series or you can expand is by the Taylor series. Firstly, I can start with this one. So can you find the first derivative of this quantity? Fine. So because it's a derivative, you have to take a 0 by 0 form. So I can simply substitute z minus n pi. I can simply choose as a h. Fine. So that the limit becomes h approaches 0. Derivative with respect to it becomes a h, because you can see that d of function with respect to z is same as with respect to the h. So I can write as a h square e raised to power n pi plus h divided by sine square of n pi plus h. Fine. Otherwise you have to write the term is minus n pi plus n pi as well in the denominator. So that will take a lot of the calculations. So better is I can change them. Now can you find the value of the numerator? So clearly say sine of n pi plus h. It will be depending upon whether say even or odd, but sine square is always the even functions. So this value is always my sine square h. Fine. E raised to power n pi is my constant. Now clearly say if you taken as a derivative, then apply as h approaches 0, it is always 0 by 0 form. Then it is not an easy target that you can apply the derivative rule. So in the opposite of that, I can start with this sine expansion series. So it is h cube over 3 factorial and so on. Because sine is the denominator, so I can write as a firstly the coefficient to the 1. It is 1 h square over 3 factorial and so on. Then I can write as a 1 over sine h, 1 over h. I can apply the expansion series 1 minus x. So this value becomes 1 plus and so on. Fine, because this series is my 1 plus x square and so on. Now you can substitute the values. Therefore h square e raised to power h over sine square h. So that number will be h square e raised to power h sine square. So it will be h square raised to power 2. H square will be cancelled. Now your target is to find the derivative. So can you find the derivative of the functions? So I can use as a product rule. First function e raised to power h as such. Fine, 3 factorial so on plus e raised to power h, derivative of this part 2 times of and 0 plus 2h over 3 factorial and so on. Fine. Now taken the limit as h approaches 0. So this value will be my 0. This value will be 0. Next value will be 0. E raised to power 0 is my 1. So I can substitute the value of this limit is my 1. Answer is e raised to power n pi is the required answer of this problem. Fine. Now look at the one. This is an exercise for you. Can you solve this problem and let me know the answer in the comment box? Say cot of z cos hyperbolic z divided by z cube. Can you find the residue of the functions? Can you find the residue of the functions at the point 0? This is example number 1. Second is tan inverse z divided by z raised to power 4 at the point z is equal to 0. Can you find the residue of the functions? And let me know your answer in the comment box. You can put the comments in such a manner that answer 1, whatever you have to obtain the answer 2 in this manner, so that I can understand it whether you are able to understand this lecture or not. तो क्या आप कमेंट करके बता सकते हैं इनके आंसर क्या है, so that everybody knows that you can understand this lecture very well. The next lecture I will upload very soon, how you can find the residue at the infinity. Till then you can share this video with your friends. Best of luck students. Happy luck.